All right, so today we're talking about absolute value transformations. So in the previous video, we talked about the linear, and absolute value is very similar. So first off, we need to look at what is a basic graph of an absolute value. Okay, it is going to be a V-shaped graph, and both arms of the absolute value, okay, have a slope of -1 on the left and a +1 on the right. All right, so we're going to look at graphing a basic, what we call the parent function of an absolute value, which is y is equal to the absolute value of x, right here. So I've picked out 5 different x values that we're going to plug in and solve. So the absolute value of a -2 is a +2. Absolute value of a -1 is a +1. Absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of 2 is 2. So I've got -2, 2, -1, 1, 0, 0, and 1, 1, and 2, 2. So I'm going to plot these 5 points on my graph. So I've got -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And I apologize for my lines not being straight. Okay. So this is what our absolute value function looks like. Okay. This is the base form that we have. So our parent function. Now looking at the domain and the range, okay, looking at my graph, I'm going to keep going to the left no matter what I do, and I'm going to keep going to the right. So we have what we call all real numbers. No matter what I pick for x, it's going to be somewhere on one of these arms. The range, remember, goes with the y. It's our up and down. Okay. Well, I'm going to keep going up, right? See, my v keeps continuing on upward. But I stop right here. And I don't go any lower than that right there. Our range is going to be y is greater than or equal to 0. All right, so now let's talk about our shifts or our translations. Okay, we have 2 types. Again, we have our horizontal and we have our vertical. So we're going to start with talking about our vertical on this. In the vertical, okay, whoop. In our vertical, okay, we're either adding something to the absolute value or we're subtracting something from the absolute value. If we are adding, it's going to shift it up that number of units. So in this case, when I've already got f of x graphed here, so we're going to shift g of x. And g of x is the absolute value of x plus 1. So that means I'm taking and I'm shifting those points I found earlier, and I'm shifting them up 1 space. Okay, so in this, my domain is all real numbers still because I'm continuing going to the left and right without ever stopping. Okay, nothing's going to cause there not to be an x that I can pick. And my range, well, I keep going up, but I stop right here at that right there, which my y value there is 1. So y is greater than or equal to 1. All right, so let's talk about now what if we're subtracting. Well, adding took us up, So subtracting is taking us down. So I'm going to take all those points and shift them down. And in this case, I'm shifting down 2. Okay, I shifted all those points down. So my domain again is all real numbers because I'm continuing going left and going right no matter what. There's no reason for my graph to stop. And my range on this time, okay, well the y value of that point is a -2. So y is greater than or equal to a -2. So we've covered our vertical, which is the up and down. So let's talk about our horizontal. So horizontal is going to deal with inside the absolute value. Okay, so inside the absolute value, if I'm subtracting something or adding something, it's going to move it left or right based on whether we're adding or subtracting. So if I'm adding h, it's going to shift to the left. Okay, so in this case, on my g of x, I'm going to shift everything to the left 1, which means all my points that are on the graph are shifting 1 to the left. As you can see, I'm kind of shifting those points that way. All right, so we've shifted a horizontal translation to the left h units because we were adding, or 1 unit because we were adding 1. Our domain, guys, is all real numbers. We've got an absolute value. Majority of the time, domain is going to be all real numbers. And the range is going to be y is greater than or equal to 0 because that point right there is the point -1, 0. So the y value is 0. Okay. All right, so let's look at our final type of translation, which is our shifting right. So just like all the others, we're taking the points and we're shifting it to the direction it tells me. So in this one, I'm shifting 3 units. So I'm going to go 1, 2, 3. And again, I'm shifting all my points that many units. My domain is all real numbers. And my range is y is greater than or equal to 0 because this is the point 3, 0. All right, so we're going to look now at what we have when we have a double transformation. Okay, all this is I'm going to work what's in the absolute value, and then I'm going to do what's outside the absolute value. So starting with what's in, okay, remember in is left and right. So in this case, I'm going to move right 3 units. So I'm going to just take the bottom point of my V, and I'm going to move that right 3. Okay, and then I'm going to use what's outside, which tells me I'm moving it up. And then I can draw my other points. Because remember, okay, the absolute value is always a V-shaped, and I've got a slope of 1 on those. So we can do both a vertical and a horizontal translation in these in one go.